So welcome everybody. We're really excited that you're here and we've really been looking forward to sharing this presentation with you tonight. As you've probably noticed, we have it set up that everyone is muted and we're not able to see you at this point. But for that reason, if you have any questions as we're going through the different presentations, please be sure to type them into the little chat room, and that little icon, it should be on the bottom of the left-hand side of your screen there. So please be sure to put any questions you have in there. What we're going to do is we're going to go through the presentations and then we'll go through the questions that you may have at the very end of all three presentations tonight. So I think that's about it for housekeeping, and I think we'll just get started here. I am Janie Ray, so I'm the CEO of BC Whales and the North Coast Cetacean Society. And I would really like to acknowledge that I'm speaking to you tonight from the unceded ancestral lands of the Namgis First Nation of Alert Bay. And our work really would not be possible without their support and local knowledge. Tonight, we're going to be sharing with you some of the work we've been doing in the last year or so regarding whale acoustics, culture, and the technology that we use to gather this data. But first, I just want to start off with a little bit of history of BC whales, which is supported by the North Coast Cetacean Society. This started over 20 years ago when we actually traveled up the coast of BC in a very small liveaboard vessel. And we arrived in the First Nations village of Hartley Bay. And this was back in 2001. At that time, we spoke with the hereditary chief, Johnny Clifton, and his wife, Helen, and community members. And we asked them for permission to build a whale research station within their territory. And not only did they give us this permission, but they also shared with us their local knowledge of whales. And so the work that we're presenting here tonight truly would not have been possible without their personal support. So these are tonight's presenters. So I'd really like to introduce you to them first before we get going here. They've been most of the presenters tonight have been working with BC Whales for a number of years, and they truly have made our research and goals possible. And that's what we're going to be talking to you about tonight. Grace is going to be speaking to you about our drone research and results. Ben will speak to you about acoustic monitoring in underwater soundscapes. And Aaron will be discussing the famous humpback whale song. So we're going to start off with Grace. And Grace actually started working with BC Whales back in 2019. She came to us as an intern, but now she's actually our station manager and project director, and truly has been doing an incredible job. And Grace tonight will highlight how drones have been an exciting and effective tool that we now use to study whales, adding incredible insight into their surface behavior and potential threats to their daily lives. So Grace, if you want to get started, that would be great.
Wonderful. Thanks so much, Janie. I'll just share my screen here and hope that all goes well with that, and then we can make a good start. So maybe if you can just give me a thumbs up that you can see my screen, that would be great. Awesome. Yeah, thanks so much, Janie. Really good to be here. Very excited to chat to everybody tonight about some of the work that we're doing, particularly up on the North Coast in Gitga'at territory. But before diving into that, I would also like to acknowledge that I'm speaking to you today from the traditional and unceded territories of the Coast Salish peoples, including the Tsleil-Waututh, Kwikwetlem, Squamish, and Musqueam nations. And as Janie mentioned, I'll be speaking a little bit more about some of the non-invasive work that we're doing, the research techniques that we use, and in particular, how drones are playing into all of that work that we're conducting up in Gitga'at territory. Okie doke. So Janie touched on this already a little bit, but this organization has been growing a lot in the past 20 years since it was founded back in 2001. And in that time, as we have been living alongside whales and learning from them, we're recognizing that there is always more to learn, and that the more we know, the better chance we have to establish effective protection measures for the whales that we're interested in particular for humpback whales, fin whales, and orca up in Gitga'at territory. And so we have been collecting data in a way that we're hoping can help to improve those protection measures, but of course needing to do that in a way where we're not negatively impacting or causing more stress to their daily lives. So that has led to a lot of creativity, as well as embracing newly developing and rapidly changing technology to develop those non-invasive approaches that we need to uphold that philosophy of learning without impact. And so we'll be touching on quite a few of these today. So especially with hydrophones, that's been phenomenal for us over the many years since Janie started this work to be able to listen to the lives of whales and non-invasively learn from them. And Erin and Ben will touch on that in a lot more detail. We've also been able to adopt methods of photo identification and looking at the tails and unique features of each whale that we see within our research area to be able to learn more in depth about some of the trends as that relates to individuals, but as well into bigger, broader populations, tracking that non-invasively just by looking through photos of the features that whales have on their bodies. We're also conducting research, as Janie mentioned, from this beautiful research station in Git-Gat territory on Finn Island. And being able to conduct so much of our work from land has been a huge help in our effort to be able to learn from whales as well as living alongside of them without having that impact on them. So as much as possible, we're using these methods from land to be able to conduct our research. And more recently, adding drones into the picture has been a huge game changer to be able to assess whale threats and whale behaviors in a way that just was not possible before without having that top-down perspective. And so we will be diving a lot more into the role of drones in a few minutes here. But before moving on to that, I just would like to highlight the law surrounding flying drones around marine mammals in Canada. Drones are aircraft, and there's a lot of laws and regulations surrounding that. But the easiest thing to remember is that it's effectively illegal to fly drones over marine mammals in Canada without a very specialized research permit. And so all of the drone footage and clips that I'll show here today have been collected under a research permit and as well by Transport Canada advanced certified pilots. So with that all in mind, we can start to dig into a bit of the details of our drone work. And so drones, again, just a game changer for non-invasive research. They've allowed us to genetically sample whales to look into their behavior as well as to assess their threats. And it's been really important as well in combining all three of these elements to get the full picture of what's going on and where protection is still needed. And so starting a little bit off here with genetics, we've been working very closely with Aideen O'Mahony, who actually completed a master's degree with us using drones as a non-invasive tool to collect genetic samples from humpback whales in Git-Gat territory. And so what that master's results showed is that these drones are effective. We are able to sequence the genomes of these whales in a way that can answer scientific questions fairly robustly, depending on what you're trying to answer. And that's giving us a really phenomenal alternative to more invasive techniques like biopsy sampling, where you're essentially darting a whale. And so drones here have been a huge game-changing tool for us to be able to get that same information without having an impact on the whale. And so Aideen has been able to continue this work and rolling it up into a PhD, which she's currently working on as we speak, finishing those efforts. And in the field, what that drone blow sample collection can look like is something like this, where the drone is able to follow along with the whale fairly slowly. And as the whale comes up to take a breath, it's able to swoop through all the droplets that are in the blow and collect that sample non-invasively. And I also just wanted to highlight what that looks like from a top-down perspective, where here, hopefully what you see is a drone, a very little drone in this circle. And as this whale is coming up for a breath, again, that drone is able to swoop through. The whale moves on without having a reaction and continues traveling on. What you see here is the drone actually traveling behind the whale so that as that whale flukes, it's able to collect that photo ID. So we can also very accurately pair that genetic sample to the individual. And what's really exciting about this as we move forward is we're going to be able to hopefully piece together how that genetic relatedness piece fits into the humpback whale sociality that we observe up on the North Coast. So genetics, again, really incredible tools that drones are providing us to be able to sample those whales non-invasively, but as well having that top-down perspective is allowing us to consider how behaviors and threats might be linked and the importance of considering them together. And so just to back up, to give a little bit of context into why we feel considering whale behaviors and threats together is so important, this here is just a map showing the results of our opportunistic marine survey sightings from 2023. And hopefully what you notice right away is there's just a high density of whales within our research area. And if we just move on here to look at humpback whale sightings on their own, hopefully what you see here is that there's also a pretty wide distribution of different behavior types that we observe in our research area. And so here we're just showing a few, with green being examples of bubble net feeding, blue being resting behavior that we see with humpback whales. And just in the interest of time today, purple is all other behaviors that we see. But again, we do see this fairly wide distribution of different behavior types occurring in different locations within our research area. And that is really important for us to recognize, because in a year's time, there will be a tanker route traveling through this region. And what you can see right away is the overlap between the sightings of whales that we have just from 1 year and where this route will be transiting through. And so for us to actually understand the severity of this threat, we do need to understand how natural behaviors might be related to threats from humans like ship strikes. And so to address that, in 2021, in collaboration with the Ships, Whales, and Acoustics in Git-Gat territory, or the SWAG project, we started to use drones to conduct focal follows of whales, both on their own as well as in groups, where we're flying the drone, placing our full attention on that group to get a better idea of their fine-scale surface movements, as well as their behavior patterns, to increase our understanding of whale habitat usage and habitat preferences, but also to increase our understanding of which behaviors might be placing these whales at heightened risk to human impacts. And so within the drone itself is a highly accurate GPS. And so what that means is, as we fly over these whales, we're able to pair very accurately what the whales are doing to where they are, which is what these tracks are showing you here on this map. And so one behavior state that we are particularly interested in is where whales are resting within our study region. And here is a video showing an example of what we call a resting traveling behavior state, where we often see whales traveling at very slow speeds just below the surface for pretty extended periods of time. And what you'll notice is, although it's visible from the drone, we can see that whale from that top-down perspective. If you were looking from a boat, you would not be able to detect this whale's presence. And so considering those discrepancies is really important when we think about how behaviors are related to threats. And so what that focal follow might look like when we put it on a map is something like this. So here the blue is showing you the time where that whale was visible with the drone, but was below the surface of the water and vulnerable to a ship strike. And the orange is showing you the time where that whale had actually broken the surface and, to a keen observer, might have been detectable from on board a vessel. And so from the amount of time that this whale was actually vulnerable to a ship strike, it was only visible for about 13% of that time. So that just highlights for us that just because a whale might not be visible, it might still be present and it might still be at great risk. And that's really interesting when we consider other behaviors like bubble net feeding and contrast how those vulnerabilities might differ. And so in bubble net feeding scenarios, typically what we observe is whales, sometimes up to 20 individuals working together to feed on herring. And there's a few roles that are partitioned within those groups, where we have some whales going below a school of herring, vocalizing a very specialized bubble net feeding call. At the same time, other whales in the group might be swimming up in tightening spirals, blowing bubbles out of their blowholes, all working together to trap and eventually feed on the herring within that bubble net. Occasionally, we do actually see bubble netters doing this on their own, where one individual might need to fulfill each of these roles. And that can look in practice something like this. So hopefully you hear the audio here as well. So visually, very different immediately to that resting traveling behavior state. So that whale has broken the surface. There's a lot of disturbance in the water. Something might be more easily detectable. And that pattern of feeding surface is fairly predictable and fairly routine in those bubble net feeding scenarios. So that when we put a bubble net feeding focal follow on a map, it can look something like this. So now, again, here, what you're looking for is that blue is still that time that that whale was visible just below the surface, and the orange was the time that that whale had actually broken the surface and might have been visible to an on-deck observer on any vessel. And so in this example, well, just to remind you that that resting traveling track whale was visible for 13% of the time it was vulnerable. This bubble net feeding whale was visible for 50% of the time that it was vulnerable. So we are starting to see some differences in terms of how behaviors are related to the ship strike vulnerability. And these are pretty preliminary results, but we are also working through 3 years of drone footage to look at how these trends might be consistent across behavior states, across group sizes, group compositions, as well as locations within our research area. So this is a pretty new and very exciting project that we're conducting in collaboration with SWAG, and we're hoping to publish by the end of the year if all goes well. One thing I'd like to point out here as well is that this follow was actually conducted from the Finn Island Research Station. So hopefully you can see this little tin roof of the cabin of where our research station is positioned. And again, just highlighting the incredible opportunity we have to study these types of things non-invasively and from shore whenever possible. Okay. And so in general, just the more we have drones in the air, the more we're able to realize that this is a huge opportunity for us to better understand the influence and the overlap of key threats and whale ecology. And so as we've seen that some natural behaviors might be influencing ship strike vulnerabilities, we're also noticing a similar pattern and how some natural behaviors might be telling us a bit more about how whales are becoming vulnerable to entanglements. And so here is an example of a behavior that we call kelp rolling, where we routinely see whales seeking out and physically interacting and rolling in patches of kelp. And so, of course, if this was a piece of netting, a piece of active fishing gear, it's really easy to imagine how this whale could have become entangled and could have had a very different end scenario. And so to address both of those things as well in tandem with each other, we're recognizing that just looking at behaviors, of course, is not enough. So we also need to be looking at what the history of scars can tell us that are present on the bodies of live whales. And so we are conducting some pretty thorough scar analysis where we're looking both top down from the drone as well as using our cameras to look at what scars are already present on the body of live whales, so that we can look into how pervasive these threats might be and how that might change in the future. And so some of these examples here, this is an example of a propeller injury of a whale that was seen for the first time this year in Git-Get territory. The first time we documented this whale, it actually had arrived already with some evidence of having been involved in a ship strike, which you can see here with these sequential lesions on its side. Here is an example of a blunt force injury on a very well-known whale named Habit. And we've been able to track her recovery from that injury through time, but with her, we're recognizing that there are still some potentially unintended consequences of that ship strike as they relate to her health. Janie noted when she first saw Habit after having her return following that injury that she's never had a calf since, when she was known to have calves prior to being hit by a vessel. So investigating these types of things together is really important as we start to piece together how all these threats are truly impacting the whales that we see in our research area. And finally, on the left here, this is an example of how this project has allowed us to document live entanglement events using our drones, as well as the importance of looking from both perspectives. So this is a resident whale named Ivory, which returns to Git-Get territory almost every year since we've first seen him. And what's really fascinating about this case, and tragic in a way, is that this entanglement was actually not visible at all when we were looking from that side-on perspective. So we had been following this whale for a long time, documenting its behavior, trying to get some more information from that photo ID, collected this dio sequence, which we actually used to be able to conduct that scar analysis piece. And there was no evidence that this whale was actively entangled. And so we were pretty shocked when we put that drone in the air and realized that there was an active entanglement around Ivory's left pectoral flipper. And so looking from both perspectives is really critical if we hope to understand these threats as well as their true impacts. And the same has been true in terms of scars that we haven't been able to see through the drone, but we have seen through the camera. So as much data as we can gather to understand these threats is really key if we hope to make a meaningful impact to improve the lives for whales along this coast. And so just to wrap up, I just want to mention that if you do ever see a whale that you believe might be in distress, the most important thing to do is to report it. And so DFO has a few means of doing this. There is an incident reporting hotline, which you can call if you're in an area of cell coverage. There is an email you can use, as well as you can always call on VHF channel 16 to Coast Guard to let them know that there is a whale that has been hit by a boat that is entangled or that might otherwise be in distress. But we do recognize that there are a lot of regions along the coast that are very remote. And so to address that a bit more directly, we've developed an app where the purpose of that is to be able to log your sightings details of whales that are in distress very accurately in real time to make sure that you don't miss anything. So it's very important still to be calling on VHF 16 to let Coast Guard know, but what is also critical is to make sure you don't forget any information before you leave the site. So the remote report app is designed to be able to allow you to very easily log that information, including exactly the coordinates where you saw that sighting, store it if you don't have internet. And as soon as an internet connection is restored, whether that's Wi-Fi, whether that's cell coverage, that report will then be automatically sent out, and it will be made sure that the correct people that need to be aware of that sighting are made aware. So this is something we're really excited about and we hope is useful for mariners all up and down the coast. And it is now available. And we hope that, that some folks are interested in downloading it. Please feel free to use these QR codes, download that app. And if you do see a whale in distress, please do report it because it could be the difference between life and death. So that's all from me. And thanks for listening. Well, you're just muted there, Janie.
Yeah, thank you so much, Grace. Yeah, I was overwhelmed. I know I've seen the presentation a couple of times, but it gets me, it actually gets me every time. And I love the difference between the bubble net feeding focal follow and the resting travel, because that's actually the first time I've seen it put together like that. And yeah, just phenomenal. Thanks so much, Grace. Thank you. So our next presenter is Ben Hendricks, and Ben's actually been working with us since 2016, and he's actually now started his own company called Soundspace Analytics. And he's developed all of the software and acoustic monitoring tools that make our work possible. And Ben's going to explain how scientists listen to the oceans to learn about ocean soundscapes amid challenges posed by noise pollution. All right, take it away, Ben.
Thank you, Janie. Just a quick thumbs up for everyone seeing the presentation here. Excellent. And fantastic, Grace. Unbelievable. It will be very hard for me to beat that imagery we just all saw in that presentation. And thanks for you all to be here with us from, I assume, in BC and beyond. I myself am located in the Comox Valley, which is the traditional territory of the Comox First Nation. And in the talk that I will be giving, I will kind of speak a little bit about rails. I will speak a little bit about ocean acoustics, and then I will also speak a little bit about computer algorithms, which of course is the most interesting part for myself. So the title of the talk is called Machines Listening for Whales, and how sound can be at the same time noise and knowledge. But before we go into computer algorithms and the detail of what ocean acoustics is about, I think I'd like you for a second to step back and imagine you are a whale. And what I'd like you specifically to recognize is how different you are from a human being. yes, you're about 10 tons heavier, but then also the sensors you use to navigate your world are very different. As humans, we're very used, for example, to find food, to track down our prey, we use our eyes. At the same time, to avoid predators, we probably spot them from far away or close by. If you're a whale, all this is done by sound. And if you navigate your world as a human to find the next superstore, you're probably doing it with your eyes or with the help of Google Maps. If you're a whale, all this is done by sound. And of course, last but not least, if you're in the mood and you're going on a date as a human, you may make your hair, you may tint your lips, you may put your nice clothes on, you may pump your muscles a bit, all features to attract the eye of the other person at the table. So if you're a whale, you're doing none of that. As a whale, you sing. So you attract the other whale with sound. Everything in the life of whales revolves around sound, and that is the important thing for us as scientists, that we get access to studying the whales through sound. And at the same time, unfortunately, because sound is so important to these whales, sound is also a threat if it's in form of noise from decibels. And I try to touch both aspects a little bit in my talk, and then Aaron will dive very closely into that, the song aspect of whales trying to date each other. So the reasons why computers are really important to have a look at acoustic data and understanding whales through sound can be explained with a project that I like to introduce, which is called the BC Hydrophone Network. On that map, you see a couple of different circles, and each of them is a hydrophone hub. So a place where one or multiple hydrophones record ocean acoustic data. The picture there is actually how a hydrophone may look like. The hydrophone itself is within that yellow sock, and everything looks quite inconspicuous, but the whole design, including bringing the data to shore, can cost about $50,000 per one of these pieces of equipment. So it is high tech, and it records 365 days a year of acoustic data that now needs to be analyzed on all these locations along the coast. And the BC Hydrophone Network makes the big step forward in trying to organize that for coastal communities, indigenous groups, and NGOs to streamline that data collection and the processing. And as you can imagine, the processing itself requires automatic computer software because humans can just not keep up with all the data that is collected year by year. What happens if whales are acoustically active, and if you don't use a computer, is you just put the hydrophone in the water and you may hear something like this. That is a bubble net feeding call from a group of whales trying to corral herring, and the concept of which introduced Grace just in the last talk. So now, having a hydrophone in the water, we can listen to this. And the next step is to plug a computer into the system and translate what we can listen to into an image of that sound. So this is shown at the bottom here. It's called a spectrogram, and it shows the energy over time that these whales put in the water. So each of these little yellow lines is one of the whale calls that you just heard in the sequence. And what the computer can do for us is it can run an algorithm and detect each individual one of those and puts it into a database. And when it gets really interesting is we can use machine learning to then identify what that sound of interest has been, which in this call, of course, is a bubbling and feeding call, one after the other. And the reason why this is possible is because each sound in the ocean pretty much has their own acoustic fingerprint. So the plot here on the right shows spectrograms of different sounds, of orca, humpback, fin whales, but also of vessels. And I think the bottom here is a sea lion Our instruments can make noise themselves. So we can collect these sounds, feed and create a big acoustic library and train these computers to be able to classify whatever they hear. And through that, you can come up with detections that you know what they are. And if you collect them over long periods of time, you start to gain knowledge. In this case, for example, when do bubble nets feed? So the plot here is simply counting the number of these detected bubble net feeding calls over the course of the full year. And the bright bars is when it happened during daytime, and the dark bars is when it happened during nighttime. And just by looking at it for a second, it becomes pretty obvious that it mostly happens in the summer and kind of peaks in August. So that is an example of what you can do by detecting calls. The next step is where we can combine acoustic monitoring and computer algorithms when we can localize these calls. And for that, we need multiple hydrophones working together, like in the area and get territory, where we do localization research as part of the Strike project. And in that area, we have 4 hydrophones monitoring one area, and when whales become vocally active, we can pinpoint their location and we can learn where whales bubble net feed, like you can see on the plot here. And then the next video is giving a time lapse. So I think this is about a week of data of locations. In this case, it's fin whale calls. And what it shows is that most of these localizations are not just dots on the map, but they're connected. It's whales moving around, being vocal while they go. So in the end, you're not just having a map with a lot of dots, but you can create tracks. So all these localizations can be combined into these, what I call spaghetti plots. And each of these spaghettis is a whale trail. It's a whale being vocal and moving, and we can reconstruct their movement. We can identify the speed. We can identify where they're going, what the heading is. And we can learn if they do something different between day and night, like we see in this example here. And just because probably most of you haven't heard a fin whale vocalization, I tried to play one here. Fin whales vocalize at a frequency that we cannot hear with our ears. So in that case, it is even necessary to use machines and computers to detect these calls and work with them, because if we would just listen to data, we would not pick it up. So let's try if we can hear anything in this clip here. So this is an audio file that has been played 10 times faster than our ears typically would listen to acoustic data. And maybe you heard a little top, 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 top. That was the fin whale. In case you haven't heard it, this file plays it 20 times faster. And now you should really all hear the fin whale calling. And this can go on for sometimes an hour or longer. While the fin whale is calling, we can localize the vocalizations and can then slowly create these tracks while the whale is moving through the water. And so after that section, I think gave a little bit of an overview how we can use sound and the vocalizations of whales to create knowledge for us. The next slides focus a little bit more on the fact that sound also can be noise. And for that, it is important, I think, to understand that for a long time, whales had conditions in the ocean that I think scientists would call pristine. So you maybe have waves and weather and other marine mammals who fill up your soundscape, but besides that, this is what you grow up, what you evolutionarily used to. And this is, in a scientific term, it's called a full listening space, and it's shown here on the right side of the plot. So you have no vessels present, and that means that you can listen and you can transmit signals to a certain distance. And in that case, it may be a group of orca that can communicate beyond with each other and that can detect fish that they're preying. And then as soon as you enter vessels into the picture, you create noise and a soundscape that now maybe goes from quiet ocean conditions that you may or may not hear in this clip to really noisy ocean conditions that sound like this. Boom. And the way that scientists try to express and quantify that impact is they try to express it as a reduction of listening space. So this is the left side of this plot, where when a vessel creates noise in an ocean environment, it reduces the space that a whale can communicate with conspecifics and that it can detect prey or avoid predators. And that's a really neat way of going about it, because now it's not a question of whether there is noise or not, but we can quantify it. We can say how much noise is brought into the oceans by vessels, pretty equivalent to how much carbon dioxide a certain type of industry is emitting into the atmosphere. And that, in my opinion, can be described as a form of acoustic fog that the whales experience, because they depend on their sound as much as we do on our eyes. So what can we do with this? The next plot here shows a spectrogram of a full day of acoustic recording. So along this axis here is the time. Here is the frequency of the sound we're recording, and the color tells us how loud it was. Everything that's blue is quiet. Everything that's yellow is loud. And we can see some whale activity in here. This here is actually a humpback song going on, but most of the big loud events, the big yellow bars that go through the picture here, is vessel noise. And those vessels create that acoustic fog and that listening space reduction that is so problematic for whales. And what we can do with computers is we can run an algorithm that detects us the time windows when whales are reducing the listening space. So we can create knowledge of how many hours per day we have that vessel noise, and we can also create knowledge of when during the day the vessel noise happens. So in the right plot, you can see that as a clock. And the more the blue color fills out the clock, the more often vessels are present during that specific day. And we have, as soon as we have this established, we can translate this into how much louder is the soundscape because of vessels? How much did vessels pollute noise into the water? And then we can determine how much does it affect the listening space of orcas and humpback and fin whales and whatever species we are interested in, and we can quantify what the vessels, how the vessels impact the whales, which hopefully helps us creating balanced marine ecosystems and manage the ecosystem so they stay healthy. So on top of all the work we can learn what whales are doing in the water, we can also use acoustics and machines to quantify and learn what our impact is on them and hopefully be able to better protect them. So the last slide I want to show is just to highlight again what the BC hydrophone network is doing. Because with all this in mind, the BCHN at the moment has 19 different hydrophones in the water and recorded so far about 14,000 days of acoustic data and detected more than 10,000 events where marine mammals are present. And that makes it one of the biggest data sets available in the world and for sure in BC. And this is a really important and great development to better understand the acoustic world of the whales and hopefully being able to better protect them. And the BCHN is not the work of a single organization, but it is really important to highlight that This is just an umbrella organization for all the individual groups who share that goal and that vision to protect the ocean through sound, and we're trying to work together to create a cohesive picture, a cohesive acoustic picture for our coast. And with this, I give it back to Jamie. You're still muted.
Thanks. Maybe when I come to you, Aaron, I won't be muted. We'll see what happens. Ben, thank you so much. I just think the work you're doing is really important to the entire coast of BC. And I really like the video of the fin whale. I think that really shows the whale trails that we keep talking about. So thank you so much, Ben. That was really wonderful. All right, our next presenter is Erin Wall, and she's just recently joined our BC Wales team, and she's now doing her postdoc with us in partnership with Orca Lab and the Rain Coast Conservation Foundation and Dan Manil. And Erin is going to share with us how listening to humpback whale songs can teach us about how they learn from each other. So take it away, Erin.
Thank you so much, Janie. All right, I'll share my screen. We'll give that a go. Okay, are you seeing the slide? Okay, just make that smaller. Awesome. Thank you, everyone. I'm just going to make that tiny. Cool. I'm excited to talk to you all today. Thank you so much for having me. I remember joining this last year as we were in talks about getting to work together. So it's great to be here talking to you today. Yeah, and before I start, I also want, because I'm talking today about learning by listening, one of the ways that we can learn from each other is to listen to the people whose land we settle on and to the traditional knowledge that can help us become better relatives to the land and to each other. So today I'm on the Seminole, Miccosukee, Tocobaga, and Muskego territories, and I just wanted to acknowledge that before we start. So yes, I'll be talking about learning by listening, mostly to whales today. And yeah, we'll start if I can get it to go. I think my computer's acting a little slow. Let's try this. Okay, looks better. Great. So to start, the discovery of humpback song is thought to have been one of the major contributions to help end commercial whaling. And the earliest recordings of whale song by Frank Watlington, Roger Payne, and Katie Payne became a multi-platinum album in 1970 that preceded the International Whaling Commission banning commercial whaling in 1982 that went into effect in 1986. And this album is here on the right. And I think one of the reasons that made such an impact was that learning that humpback whales sing had such a profound impact on all of us for the cultural appreciation that it gave us of the humpback whales. And it really drew public attention to humpback whales at that time. And part of that might be because it resonated with us because it reminds us of music and the way that we communicate and express ourselves to each other. Humpback songs are repetitive, they're structured. Here you can see this visualization of the humpback song. It's an artistic visualization of the different units of their song on a music staff. And you can probably see here that there is this pattern. And this pattern is this hierarchical structure that does in many ways resemble human music, even though they are very different. So it sounds to us expressive, which is something we do with music. And not only do they use this song to communicate with each other, they also learn their songs just like we do. And this is actually a rare trait in the animal kingdom. We share it with just a few animals, which I'll show you right now. So we share this trait with seals, with elephants, with bats, songbirds, who I used to study, humans, that's me, and with whales, of course. So, and this trait is called vocal learning. By listening to our parents and people around us during development early in life, we learn the vocalizations that we need to use to communicate. And what's cool about whales and about us is that we not only learn how to sing or how to communicate with each other during development, we also continue to learn throughout our lives. So humpbacks do this amazing thing called cultural transmission, and it's this social learning from each other where as the years go on, as they are with their populations that they sing and learn with, these songs are gradually changing collectively. So within a given population, humpback whales will sing roughly the same song, but new variations can be introduced, and that gets picked up by the others through the process of cultural transmission. And while we can observe this, and there's been some really amazing work on this since the discovery of humpback whales, we don't know much about how this is learned or the process of song development. We think that it's social, but there's a lot that we can still learn about what types of social interactions are important for this process of learning and the acoustic exchange between different populations that might be important for shaping this song. So with all of that, we have a lot to learn still about humpback song and about learning. And while these humpback whales thankfully don't have to face the threat of commercial whaling here in Canada anymore, they do still face many threats, including climate change, vessel strike and entanglement, and as been introduced, the human impacts or the human activity such as vessel noise. And since it has been said by some research that vessel noise in the Pacific has been doubling each decade since the 1950s, this vessel noise really does have a potential major influence on learning. We know a bit about how vessel noise is impacting cetaceans. So for humpback whales and other cetaceans, their acoustic environment is critical to their communication. It's also critical to foraging, navigation, mating, and ultimately their survival. So on this plot, it's a spectrogram, which I'll introduce to you again on the next slide, where frequency or pitch is on the y-axis and time is on the x-axis. And then we have amplitude and color. And you can see on the left the structured humpback song. And as soon as a vessel noise comes into that acoustic environment, you're no longer able to see that song. And as Ben mentioned, that's really masking their song in these instances, limiting the communication space and therefore limiting how far these songs can travel and be heard by other whales. And as we're learning, of course, together, listening is critical for learning. So if they're not reaching these other whales, this could be limiting their ability to culturally transmit their songs or learn their songs and communicate with each other. And we also know from many species of cetaceans that vessel noise can impact and change behavior. So they can potentially be modifying the features of their vocal behavior or how long they sing. It can also cause them to stop singing altogether. But it will be critical for us to understand what impacts this might have on learning. And we can look at that here in the feeding grounds. We have this very rare and exciting opportunity through the BC Hydrophone Network and for all of the partners who are involved and with, of course, BC Whales to learn by listening here on the feeding grounds to song. And so I'll show you these two examples. We'll get to listen to them. And if you have dogs, just be ready for them to perk up at these sounds. And this is, if I can get my cursor. Hello. There we go. This is an example that we were all very excited to hear on the Finn Island Research Station this past fall.
I can't hear anything, Erin, just so you know.
Oh, oops. Okay, let me fix that real quick. Sorry. Now, I guess you might not have heard the song earlier as well. I might have. Yes, hold on. Thank you for. Let's try this again. Okay, let's try again. You let me know. Yeah or no? Okay. All right, and this is another example of another theme being sung by a whale in Orca Lab area. This past fall. yeah, so through that amazing field experience and through all of the amazing acoustic data that the BC Hydrophone Network and BC Wales and Ben have facilitated, we are doing this project for my postdoc called Singing to be Heard, where we get to look at that humpback song on the feeding grounds. And this is with, of course, Janie and with Dr. Valeria Vergara, hi Valeria, with Rain Coast Conservation Foundation, and with Professor Dan Minnell at the University of Windsor. So and together, these partners are also working with the broader collaborative network, which is very exciting. So I've listed them here in sort of north to south coast. And you can see the hydrophones here in green and yellow among the map. And so we have, of course, BC Wales, the Gitga'at First Nation, the Kitasoo Hey Hey, Helsik, Orca Lab, Rain Coast, Simres, and all together, Whale Sound, and of course, Ben, sound space analytics. Looking at sound and song on the feeding grounds. And the questions that I'm excited to ask and that I'm working on right now and excited to share more with you in the future involve looking at how does humpback song develop during the season across multiple years across the BC coast, and how are these themes being incorporated and the variability of song and how that practice develops their song over the season, and how these interactions could be shaping behavior, both through the individual social interactions that are occurring between one whale and another, which we can use the localization to ask, and of course, just the acoustics alone when we have overlapping singers, and through the acoustic exchange between populations. So when they're on the feeding grounds, multiple breeding populations are sharing the feeding grounds together, and this could be critical for the development of their song and the exchange of song through cultural transmission. And of course, we will look at how is vessel noise affecting singing, specifically this song development or seasonal song learning. So since we know that vessel noise can have such an impact on their behavior, we want to understand the impact of vessel noise that might be important for protecting the critical marine acoustic environments that they need for this learning. There we go. And so together for this collaborative project, through my postdoc, I'm just elated to get to talk to you again in the future with the results of looking at song learning here on the North Pacific feeding grounds. And with that, that is it. I'm excited for everyone's questions. Thank you so much for having me. And thank you for all of the partners and of course, MyTax for facilitating this project for my postdoc. Thank you.
Oh, thank you. Thank you so much, Erin. I am, as you know, extremely excited about this project, and really looking forward to really diving in and getting some of those results, and we can share that with everybody perhaps next year at this time. But thank you so much for the work you're doing. It's really important. It really is important work.
Thank you.
I'm just going to share my screen for a couple of minutes, and then we can get into the question and answer portion of the presentation. So just bear with me for 1 second. Okay, great. I just wanted to follow up to what Ben was speaking about for just a couple of minutes, and that's about the BC Hydrophone Network, which is an incredible collaboration between NGOs and First Nation communities, really working together to understand the entire soundscape of British Columbia. And as Ben mentioned, we have close to 18 hydrophones in the water, and that's about to grow. We're probably going to go up to 23, 25 by the end of 2024. So we really are listening, but it really is a project about collaboration and partnership. And I think that we all understand that that really is the only way we're ever going to find a way to truly protect whales and understand the impact of vessel noise on whales and their habitat. But just to let you know, there is a website. It's called Whale Sound, and you can go to the website, and there's a number of different pages, but one of the pages is an interactive map, and you can go on to this map. It would look like this. And if you click on one of these circles, it'll take you into a number of hydrophones. And if you click on one of those hydrophones, it'll actually take you to a dashboard. And the dashboard is called CStats. And this is something that Ben actually developed for us. And Once you're on the dashboard, you can look at different whale events. So you can look to see how many cetaceans you may have had at that particular location for the week, for the month, for the year. And you could also compare different whales. So you could be comparing orcas to fin whales to humpback whales. But there's also other buttons you can click on the dashboard that would take you to the soundscape, the ocean noise levels, the vessel noise levels. And we're pretty excited about the project. It's pretty new for us. So I really hope that you have a chance to visit that website, and it's going to be, it is whalesound.ca. And with that, always, I mean, there's so many people we have to thank that support the work that we do, and they're all listed here, but I really want to just name off a few. I know you can read everything on your own, but Fisheries and Oceans Canada has supported a lot of the projects that we do through the HSP, Habitat Stewardship projects, as well as the Nature Fund. Save Our Seas has helped us for over a decade. The Make Way Foundation, the Donner Canadian Foundation has been with us as well for a number of years. And the Willow Grove Foundation has really been with us from the very beginning. And the support of the Gitga'at First Nation actually allowing us to build this research station within their territory and sharing their knowledge. And of course, that has grown over time. And there's just been so many people and so many volunteers and interns over the years that have been with us from the very beginning. So I just want to give a big thanks to everybody on that front. And now we can open it up for questions. And I'm just going to open that up right now for myself, and I'll read them out. And as I'm reading them out, if you think of any other questions you'd like to add, please feel free to do so. I'll start at the beginning. Okay. Thank you, Karen, for asking this question. Sorry, I just make sure I start at the top here. Yeah, it's at the top. Okay. Karen Hansen, nice to see that you're here, Karen. Grace, I'll have you follow up with this. Karen's asking whether ivory, the whale that you showed that was entangled, was ever seen again.
That's a great question. There was a lot that unfolded with that story, involving many hours and days on the water trying to re-find that whale, to be able to attach a satellite buoy to track and allow for a disentanglement to occur. The short of the very long and incredible effort, both from ourselves, the Gitga'at First Nation, as well as some other operators that were in the area, is that we weren't able to find ivory again while he was actively entangled. But the really positive news is close to the end of our field season, the next year, we actually saw ivory. So that was a very emotional moment. I think I dropped to my knees when I learned that we had seen ivory alive, and very happy to report that he is alive. And hopefully, I believe we got some really good drone footage of him again this past season, so that we can incorporate that into our scar analysis, knowing that he was actively entangled. So thanks for being concerned and following up about how he's doing these days.
Thank you, Grace, and thank you, Karen. This is a really important question from John Harper. He's asking, can you be absolutely sure that drones don't impact the behavior of whales? It's a great question.
Yeah, it's a great question. I'm sure Janie and I would answer this very similarly. So maybe I'll start, and Janie, if you have anything else to add, please do. But we are very, very conscious of the potential impacts that drones could cause in terms of whale behavior. And for each single one of our drone flights, we actually actively monitor and have a scale to monitor behavioral response. It does occasionally happen where whales react to the drone. And if that occurs, we end the flight right away. We just come back off the whale and let it continue on without the drone overhead. But for more than 80% of our drone flights, we don't observe any behavioral response.
Yeah, and from the very beginning, when we first put a drone in the air, we've documented and scaled. We have a scale that we follow in case of any kind of reaction. And as Grace had mentioned, it's very rare. One thing that we never do is if a whale is resting or sleeping, we would never, sometimes whales rest, they're just floating, they're not actually moving. We don't actually put a drone over a resting whale because the first time we ever did, there was a reaction, and we've just never done it since. But the other thing about drones nowadays is they have such incredible telephoto lenses that you can actually be up pretty high in the sky You don't have to come down very low at all. So that's also really helping in that respect. Patricia Lang. Oh, Patricia's here. Hi, Patricia. I'm so glad you're here. We've got to talk. So this is a question about the reporting app. Is the reporting app also used to report any other whale sightings on the coast?
Yeah, I'll just jump in there again, I suppose.
Absolutely.
First of all, hi Patricia, great to see that you're here. Hope to connect with you again as we head into the upcoming field season. But right now, this app is really focused on whales that are in distress, that are actively entangled or have been hit by a vessel. Actually, the same is true for any marine mammal. Of course, today we talk about whales, but this is an app used for any marine mammal that is in distress, entangled, or that has been hit by a ship. There are some phenomenal apps that already exist out there in the world to just log sightings of whales. And so the purpose of this really is to focus on being sure that we're able to document effectively what to do and what to collect when you see a whale that's in distress. So thanks for that question.
Oh, that's great. Another question from Julia Rankin. She's asking whether ivory was freed as well. So I think people are quite interested in that. Interesting question. How many certified drone operators are being used along the coast of BC? I would say not very many, but I don't know the exact number. But off the top of my head, I only know of 4 or 5, actually. What about you, Grace? Can you give that a different number?
I think that's in the right ballpark. I think each organization that's really actively using drones for their research might have 1 or 2 pilots. So it is a really small community of people that have put the effort into learning how to do this work and to get that appropriate certification and research license. So just because of all the regulations you have to follow, thankfully right now it's only a handful of people that are doing this work in a really meaningful way.
Yeah, that's a good answer. John Harper has another question. Resting humpback whales, absolutely no acoustic signature as a question. And if I'm understanding the question properly, that would be true. When whales are resting, they are not vocal. They're very rarely vocal, especially humpback whales as well as orca. I hope that's the question you're asking us, but yes, when they're resting, they're quiet. Ben, did you want to say anything else to that?
No, I think I would agree. I think if that question aims at the fact that often whales will stay acoustically non-detectable, then this is absolutely right. If it's from a perspective of how they're moving, then I could add, and probably Aaron would confirm, that when they're singing, often their body is in a resting position, so they would just hang in the water while they're producing their song. So they can be vocal while they're not active otherwise, but there's definitely good periods of time when there's no vocal activity.
Good, thank you. Next question, and I apologize if I mispronounce your name. I think it's Leia Valor from Barcelona. Well, that's wonderful. Or maybe that's your last name. I could be getting that wrong. This is a good question. I would like to know your opinion about the methodology of tagging cetaceans for research. Do you think this is a necessary way to research in combination with these then the way that you explained? So we ourselves have chosen not to tag whales for a number of different reasons. We're trying to do all of our research without having an impact. It is our philosophy not to, but that's not to say for those that are tagging, there's definitely incredible results that have come from the tagging of whales. It's just that for ourselves personally, we just choose not to. So it's just a choice that we're making. But that's not to say that the data that is collected is not useful, because it actually truly is. But yeah, Grace or Ben or Aaron, did you want to say anything to that?
I think that covers it really well. I think tagging data can be useful depending on the question that you would like to answer. But for us, it's really important to first consider, can we answer that question in a non-invasive way before you consider going down an invasive path? So it depends a lot on what you want to answer and if you're willing to have that impact to answer it, if it's that important.
Yeah, that's well said, Grace. All right. Next question is from Julia Rankin to Ben. What is the impact of whale watching boats on the listening space of whales? I hope this data can be used to reduce the time and distance of whale watching industry. Great work. Thank you.
Yes, and I would agree with your hope that the whale watching industry definitely does have a noise impact on the soundscape and by that on the listening space of whales. At the same time, I think it's important to point out that there is not a single bad player if it comes to ocean noise. It's a cumulative effect, and a Coast Guard vessel rescuing another party may create a similar amount of ocean noise than the whale watching industry for a completely different purpose, of course. So the way we approach it is when a hydrophone is in the water, there's no distinction between who's creating the noise. It's the amount of noise that's there over time that counts, and certain vessels do create more than others. Typically, it's a question of size and speed. But I do believe what definitely needs to be in the awareness of people is that the whale watching industry does approach whales on purpose, so they probably tend to be closer to them and by that affect them more with noise levels than vessels who are on their predefined industrial routes and don't make a specific approach.
Well said, Ben. Thank you. Okay, the next question is from Valeria Vergara. Sorry. Oh, and just so happy that you're here, Valeria. And I'll read the whole thing because I think it's great. She's very excited about this project, as she should be, because she's helping us with it. And it's super important work. It really is. And her question, Erin, is your project is a little bit like a novel that unfolds. What are you most curious about finding out?
I love that question because we're always talking about what a beautifully rich data set this is and how many questions we have to answer and how many we want to answer. And of course, I've been thinking about this very actively as we're developing, the first paper. So I think the things that I'm most curious about in general, and I think this will extend, through the project and hopefully into the next steps is really what are those types of social interactions that are critical to this learning. And I think by really honing in and identifying that the changes in song, if we can explain to a degree the source of how these changes work and to get to witness one of those moments where, we've seen in the data that a variant in a song might then sort of propagate like a pop song through the population, and to witness a moment where that begins between an interaction, I think would be very, very exciting. And then I think also can help. I'm so excited to learn as I meet with more people across the coast about mitigation strategies that we may be able to observe, implement, and then test to see what is really helping and what we can advocate for to help, really create a safe and learning environment for these humpbacks. So yeah, I think that's what I'm most curious about. Thank you, Valeria.
Yeah, thank you, Valeria, and thank you, Erin. That's very well said. Okay, John Harper. The Port of Vancouver has provided incentives to quieter ships entering the port. Is anything like that in place for Kitimat? Ben, do you want to take that one, or do you want me to?
I think I'll give that one to you. That sounds more like a management question than a technical one.
Yeah, I wish we could get Tom on here because he would really be able to answer this very well. Yes and no. I mean, there is definitely incentive, and there's a lot of communication that's happening in that regard right now, especially with LNG, with these LNG projects. And it is not something that they have to do, but it is recommended that they start to look at getting proper props. So if you get certain props produce less noise, and that is the road that we would like all of these large vessels to go down. But at this point in time, as far as I know, there's incentive, but I don't know that anything is actually moved in regards to the shipping that's going to be going into Kitimat. I don't think, that's the short of the long of that I'm aware of. Unless, Ben, you know anything else beyond that?
No, not really. I think maybe what I can add to that picture is that sometimes it's not just the kind of the predefined noise of a vessel type, but how fast the vessel goes also makes a big difference on how noisy it is. And so by reducing the speed, it is at least hope that you can reduce noise levels. That's something that the research community is still trying to grasp how that actually works and how effective it is. But it is a hope that it can have an effect. So if it comes to how noisy a vessel is, by slowing them down, this can also be a, a measure to try to bring the noise levels down. On top, of course, of hopefully having lower risk strike risks.
Yeah, no, absolutely slowing down, but also the prop. And again, I wish that we could get Tom on that one. He would be the one to really answer that question, but not today. But speaking of Tom Dakin also has a question. And Grace, I'm hoping you know the answer to this. I could guess. How many DNA samples can be collected each season? So I'm assuming we're talking about the blow sampling. I think we got our huge number last year just because there were so many whales. Do you know what the exact number was?
I believe it was in the ballpark of 150 samples collected. So it just depends a lot on A, how many whales are around, and B, what the environmental conditions are like. There's been seasons, as you know, Tom, where we've had to shut down really early and we have not had the same opportunity to collect samples. So those two things really align for us this year. And I think we have about 150 samples from one season of effort, which was phenomenal.
Thank you, Grace. Yeah, that's great. Okay, we have another question. And again, I do apologize if I mispronounce. I didn't, and I also didn't put my glasses on, which was anyway. This is from John Prasii, and he's saying thank you to us all, which is wonderful. It's John and Lori, and Lori's last name is Beeman, and they're in Secret Cove on Sechelt Nation lands and waters. And he's a member of the OPP Ocean Protection Plan since 2016. So his question's for you, Ben. For Ben, do you work with the OPP hydrophone scientists in the oh, I'm so sorry.
I think it's one of Puka's train.
Yeah, thank you. Yeah. Oh, you can see it. Okay, great. And yeah, so can you answer that question?
I'm not working actively with the OPP team, but which may include Swain Weigel, but I'm not 100% sure who you're referring to. I'm aware of the work they're putting out. If it's in published form, then that's obviously something we follow really closely because a lot of the metrics and the ideas of how to measure and quantify these impacts is not set in stone, but it is a field where the community is talking a lot. And I definitely do echo your last statement here that you were really concerned when you heard about the constant ship noise and that the southern residents having a serious issue with that ship noise. From my perspective, as we start to analyze more and more of the BC Hydrophone Network data, this is still anecdotal at this point, but starting to compare the different sites and the different areas, it does jump off the page how the Salish Sea is noisy and how other areas along the coast still have the advantage of maybe having a chance of staying in that hopefully balanced state. So I absolutely agree that Salish Sea stands out in terms of noisiness, and hopefully something can be done about it.
Thank you, Ben. The next question is from Diana Wankel. I'm curious why the tankers are taking almost the same path as the whales. Is there a less invasive route they could take? Yes, there definitely is a less invasive route. Well, there definitely is. Unfortunately, we don't have control over that. They are taking the route that's probably most economic, gets them there as fast as possible. And as well, it's a route. There's only one way to get up to Kitimat, for example. You have no other choice but to go the route that they're taking. And that's where they decided to build the port for these tankers. So yeah, and I think, you know, the way when you look at the abundance of whales along the coast of BC, there's almost nowhere now that you can go where there aren't a lot of humpback whales, especially. And of course, orca are always traveling up and down the entire coast. The area that we do most of our work in, there's definitely a large population of fin whales, which is unique. And we certainly wish that they would travel elsewhere, but that's not going to happen, unfortunately, at this point in time anyway. But we will document it very, very well. Oh, and John Harper just came back to say, thank you, Janie. You answered my question. It was about the breasting whales, about it being very quiet and super vulnerable. Very true. Oh, and okay. Oh, oops. Oh, thank you. I pronounced the name properly. There we go. Oh, this is a great question. And I'm I'm going to try the name Yasmin. I don't know if it would be possible, but have you ever recorded sounds of animals that seem to be communicating between species, as if two different species were in the same region and could somehow emit a specific sound for that moment? That's a beautiful question. Grace, do you want to try that one, or Ben? I mean, I could go for it, but
I think Ben or Janie, you can start there on that one.
yeah, so I mean, of course, there are times when we have orca, for example, and humpbacks that are vocalizing at the same time. We've never ever heard them cross communicate or communicate with each other. But one thing that we noted, this is many, many years ago, when the humpback population was really growing up in Git-Gat territory, and we were listening to a lot of these bubble net feeding calls. And the first few times that this started to happen, we'd have a group of orca that would come through. And what we noted is that when the bubble net feeding call would start, the orca vocalizations would go quiet. And then once the bubble net feeding call was finished, the orca would communicate again. And so we don't know, but it appeared as though they were listening to the bubble net feeding call. But we've never heard humpback whales actually listen to the orca in the same way. So it's a very hard question to answer. At this point, I'd have to say that the answer would be no, but they could definitely hear each other. They're definitely listening to each other. I mean, I think we can recognize that, and you know, we can't say 100%, but we're quite sure that they're listening. They can hear each other, but they're not communicating with each other as far as we know so far.
And I think it's important.
I think Aaron might find out something different along the line, but we'll see. Sorry, Ben, what were you going to say?
Well, I thought it's important probably to say that from visual observations, we do observe them interacting physically in the water, different species being together and obviously reacting to each other. So there's definitely an interaction there. And probably it's a great question because it gives me the opportunity to highlight how extremely difficult it is to learn from whales, which just are a species who are mostly gunned and not visible. And even when we try to listen to their acoustics, it's really hard to study a species that is so remote as they are, and so much more difficult than with many, many land species who we have better control in observing in multiple ways, or even bringing them in the lab from time to time. So it's something where which makes the field being excited to be a researcher in, but it's also a lot of questions that we have absolutely no clue yet what we're seeing and what it's for, and the question that you ask, I think, is part of that.
Yeah.
I'd like to add, I guess, from thinking about animals that use sound generally, they're often, using their voice, even if it would be hard to observe, I guess, the exchange between two different species if they are using their own, voice or their vocalizations that are specific to them. Because in animals that are communicating, yes, many of them are very good at turn taking. So I speak, you speak, I speak, you speak. But if there's any kind of overlap, which would be natural because maybe they don't interact that much and so they're not used to each other, or if they're not using different vocalizations, or if they are, but we don't know the function of them because we don't have the opportunity to observe them enough to really correlate the behavior with that. So I think it would be amazing to see that. And I hope, with new technologies, we can get a chance to see some of these interactions, but especially, in these instances where we're beginning to learn the functions of some of these calls. But great question for the future.
Yeah, and that's a great response there. And that's actually very true, because we don't actually know when they're communicating, why they're communicating, what they're saying. So it's really hard for us to know when two species are vocal around the same time. Are they communicating with each other? Yeah, it's a phenomenal question. Okay, Jeff Reynolds, do you know if the tankers that will be transiting through these waters in the future will have dedicated whale watchers on board? Will they be using any infrared cameras to search for whales during the night? So happy somebody's asking that question, because we talked about that earlier today, and as well at a meeting that we were just in last week. And supposedly, some of these LNG tankers are now talking about putting these infrared cameras on their vessels, because one of the greatest worries that we have is when these tankers transit through at night. A lot of whales are actually closer to the surface during the nighttime, and they're more vulnerable to a vessel strike. So the idea of these infrared cameras is a really great idea. In regards to having whale watchers on the boat, that is something we're really hoping that they will have. It's something that's being recommended. I don't know if they've committed themselves to it as of yet. Maybe Grace or Ben, you might have more to say on that.
Sure, yeah, I can add a little bit to that. I think as well with the infrared camera question, currently LNG is in the process of developing their marine mammal monitoring and their mitigation plan. So none of these methods to avoid those strikes are actually set in stone. They're just in conversation at this point. And as well as Janie mentioned, a lot of whales are closer to the surface at night, which poses a great risk. But the other unfortunate reality that we do need to consider is if there is infrared cameras and if there are observers, what does that mean? Can these tankers actually do anything, or are they just going to watch themselves hit a whale? So we are really interested to see what their proposals are in terms of what those mitigations will be, and if they will actually be sufficient. So from where we're positioned on Finn Island, we're really keen as well to be a third party observing to see if they're following what they're setting out to do and to see if it's effective. So hopefully that answers your question, but I think at this stage, nothing is set in stone.
Thank you, Grace. Julia Rankin, how much does it cost to set up a hydrophone? The hydrophones that we're using up and down the coast, the whole setup is about $30,000 plus, actually, because everything's going up in price these days. But it is about $30,000 to set up one of these hydrophone stations. So it's not cheap, but effective. Oh, can you see this question, Erin?
Yes, yeah, I am excited by this question. Is
Okay.
it okay if I take that on?
Oh no, definitely.
It's a wonderful question, and it is particularly hard. So, vocal learning, as I talked about, is something that for all of the species that learn their vocalizations, they do it throughout early life and development. So they need to hear those sounds in order to learn to produce them. But just like us, they also have what we call adult plasticity. So they continue to learn throughout their whole lives. So we can observe the more adult, exchange of songs across every season, since they continue to incorporate new elements into their song. But in order to study the young whales, which of course I would love to do, it is a little bit more tricky. So there's there's some recent, very, few studies, but there's recent studies that are looking at the sort of vocalizations, or the quieter vocalizations in young whales. There is some, I saw some tagging as well that's being used to look at the exchange of song with younger whales. And then there's another researcher, Dr. Ellen Garland, who is working on a project in the next couple of years to study, how is song affected by that factor of age. So looking at that sort of vertical or young age developmental learning of song. So Of course, we will look if we have the opportunity, but at the very least, we'll be looking at also that song that they learned throughout their life from each other. And I think it takes about 4 to 10 years for them to reach sexual maturity. So that period of learning could be very long. In humans, it's those first few years, and there's different stages of learning that I won't get too much far into, but yeah, it could be a very long process for the humpbacks. I also wanted to, just while I see it, add what Valeria added to that question of the exchange between species. And she says that humpbacks definitely know to differentiate between bigs, marine mammal eaters, and resident fish eaters. And one way they can do that is through learning to distinguish them from their different sounds. And we know that seals do that too. So yes, the more we can learn about that perceptual side of how they are interpreting the sounds, the better. And I'm very excited to learn more with you all.
Yeah, no, thank you for bringing that up, Valeria. It's so true because I think we do know that up and down the coast, often humpback whales will literally charge or perhaps chase out transients or bigs, but pretty much ignore the residents. So you're right. They definitely can tell the difference. They are listening. Yeah. Katie is here, Katie Hall. So Katie was actually an intern with us up on Finn Island a number of years ago. So Katie, it's lovely to see that you're here. And she has a question. When is the tanker route supposed to start running? Do you envision any impacts or changes to your research once that starts up? That's a very good question, Katie. I'll answer the first part. We were told in early 2025, a week ago, and then just today we were told that it might be as soon as at the end of 2024. So we might be seeing these tankers going through the area sooner than we thought. It'll definitely make a lot of changes to our research. We actually just had a science advisory meeting this week where we brought a number of people into a room to discuss how can we best ensure that all the baseline data that we're gathering, the data that we collect this year, and then going forward, how can we best document whatever change is about to happen in this particular environment, because the soundscape for these whales is about to change dramatically. Right now, it's a very, very quiet soundscape. Suddenly, it's about to become very, very noisy. They're about to have these large tankers going through their habitat, which they've never experienced in this particular area anyway. So we're going to document that change and just do a really good job on the before and the after. And maybe Grace or Ben, you might want to follow up with that as well.
Yeah, I can add a little bit to it. I think this year is going to be really critical for us in terms of the data that we collect and if we need to make any changes to how we collect it, because we do need to have a pretty solid baseline of understanding. It could be a problem if we decided to change methods once the tankers come through. So of course, we want this year to be really important in terms of how we collect the data so that we can collect it in the same meaningful way going forward to be able to make those comparisons as strong as possible.
Yeah, no,
exactly. I think the questions that we ask change maybe a little bit as when the tankers are in, because our focus may be a little bit different in what we're looking for. With the acoustics, it's I think important to recognize that the acoustic fog and the listening space reduction is not only a problem for the whales, it's also a problem for us scientists, because our listening space is reduced as well. So when there's tanker noise, there's less opportunity for us to pick up whale vocalizations when they're there. So it's just another bad effect those tankers will have on understanding whales.
Yeah. Yeah, no, it's very true. Thank you, Ben. Thank you, Grace. Well, and that was actually the last question, and I think it is a really great place to end it. I really do, and I just want to thank all three of you. I think the work that you're doing is incredible, and I just am so grateful to have you as a part of BC Wales. It's a wonderful team here today. And thank you, everybody that joined us tonight. I hope that you learned something. And if you think of any questions after the presentation, by all means, just send us a quick email. It's bcwales.org. If you go to the website, just please reach out to us at any time. And with that, we'll say goodnight to everybody and wish you a wonderful weekend.
Thanks, everybody.
Yes.
Thank
Awesome.
you all. Thanks, Jeannie.